if you use double angle, here's the solution you come up with, okay? And we generated all these values out, and I actually recommend, particularly for this question, because I'm trying to illustrate something here, right? That you draw your table of values, and going up to n equals 3 is plenty, okay? That's, that's 12 values. So that's a lot of work, actually, to evaluate all of those. But then, the solution that the textbook provided, it's actually BlueFits, I think, from memory, is this solution, okay? Now, I told you, and you kind of took it for granted, that these two were equivalent because I said so, but that's the proof, okay? You can see, well, let's sort of count through it. For instance, you got 0 here, check. Pi on 2, where does that come up? Down here. Well, it actually comes up in a different column as what you might expect, right? So it lines up with this set of solutions. Pi is here, 3 pi on 2 comes up over here, and I could keep going, you sort of get the idea, right? You can see the pattern is sufficient that all of the solutions are getting it covered. So my question to you was, well, if these two solutions are valid, how did they even arrive at this other solution? Like, what else could you really do with this thing, okay? Now, I'm going to show you the way that they get it. And even though in this question, either of these really are fine, okay? It wouldn't matter which method you chose, which identities you chose. Later on, there will be questions where you need to use this second method, okay? Because the first method won't be sufficient. And I'll show you the exact question that I'm referring to in 22E once we're done, okay? So let's have a look at this thing. Well, actually, before we look at how to solve this, let me draw your attention back to this. Now, I said the clue, the hint, was all about that 3, okay? That sort of gives you a hint as to what identities you're going to need to use. Now, recall with me, this is only the third lesson that we've known our general solution forms, okay? So for tan, cos, and sine, okay, what are the general solutions? Do you remember? Let's start with the easiest one. At the front of tan, it's n pi, right? Plus, well, related angle, either call it theta, say pi on 6, or other angles, pi on 2, pi on 3, or we could just call it tan inverse of whatever's out the front here, on the other side. I'm just going to call it theta for now, because I think you know what it's talking about by now. Okay, cosine. Yeah, good. The period is doubled, right? But also we had to go back and forth. You had to go to the left and to the right to get both of the solutions that you wanted. Okay? And then lastly, sine the weirdo one, okay, has this switch in the middle, which is really, really smart. Sometimes it goes left, sometimes it goes right, depending on whether it's odd or even values. Okay? Now these are it. These are all of the forms for a general solution. Okay? So if you have the general solution for something, when you have a look at these, it has to come from one of these 3. There are no other options. Okay? They might be fiddled around a little bit, there might be different related angles, but essentially the basic idea has to come from one of these. Now when you look at this, which form does it match up to? There's only one which has a plus minus in it, right? Namely, cosine, okay? So we're sort of ditching this and this as the means by which they arrived at this solution, but there's an on 3 here, right? Now, if there's an on 3 there, that means at some stage during their solution, they must have divided everything through by 3, okay? Including this angle on the end, right? So what that implies, if this is our solution here, okay, is that where they got it from is that this 3 used to be over here, right? We saw that when we brought this down to 2x's. You got 2x equals blah, 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 blah. You get your general solution, and then you have to divide by 2 to get x, okay? Well, clearly they've done the same thing here, but with 3, okay? So this equation must have actually looked like this to begin with. Okay, now the question is, why is there a 3x there? Or how is there a 3x there? Where can you get a 3x out of this? Well, you can sort of see a 3 up in there, right? If we wanted to shove a 3x in there, you could do this. Okay? And you're like, well, is that a helpful way to do it? When you expand that out, right? I'm just going to leave this sine 2x for a second. You're going to get sine, this is just our regular old sine expansion. Sine A cos B plus cos A sine B. Okay? So far so good. Now you might think, okay, well what am I going to have to do to this sine 2x in order to get it to interact with this? Well, the normal way that you would break down sine 2x is with double angle, right? So you get 2 sine x cos x. But that's a problem, okay? Because then you've got if I had a minus 2 sine x cos x over here, okay? Even though that seems a little simpler than this, at least everything's in terms of x's and I have x's over here, at this point you're stuck. You really can't do very much, okay? There's no term which factorizes which all three of them, so I can't factorize properly in order to get a solution, okay? So this is not a useful way to go. So what do? Well, you remember that in the end I'm going to get 3x's, right? All the way through. So there is actually a 3x hiding in there in a very similar way that it's hiding here, right? Because I can write 2x as 3x minus x, okay? And you're like, really? That seems like it's going to make, I had 2 terms before, and now in a second, I'm going to get 4, right? Which we are. Let's write them down. I'm going to get minus, and just be careful with your brackets here, 3x cos x. So this looks drastically worse, right? I've doubled the number of terms that I've got, and the terms that I've got look a lot worse. But it's not that bad, right? What happens here? Yeah, that's right. Because these two are conjugates of each other, right? And the way that these identities work, there's a lot of symmetry to it, okay? So this term here and this term here will cancel, okay? Leaving me with this and a double negative, so I'm going to get this. And that's where the 3x comes from. Can you see it? Now, by the way, because I've got 0 on the right-hand side, I actually don't need to worry about that too. It's just going to be this, cos 3x sine x is equal to 0. Then you break it apart. And I think you guys could probably take over from here, right? And in fact, even from that line, you may be able to see exactly where these two come out, okay? Now, like I said, for this particular question, you really could have gone either way, okay? You could have gotten, I don't think either solution looks prettier than the other. It's not like for one you get just one solution and this one you got 2. So they're equal. But if you have a look in your booklet, the same exercise, this is question 30, what was it, 32? Something like that. Yeah, this is 32. If you have a look at a question later on, question 49, which starts off very similar, but can you see the subtle difference in question 49 means that you really have to go this way, right? If you go the double angle route, okay, you break that sine 4x apart into 2, and so the left-hand side will be nice, but your right-hand side will still be a problem. You can't break up that 3x nicely. You're going to end up with things that are still different signs. So you need to have this breakup because it removes all the terms really nicely and neatly, okay? So all this to say, remember all of your identities as you go about this, right? T method, auxiliary angle, general solution, even though we've treated them separately, they're really quite continuous with all the stuff we looked at on trig expansions, trig identities, trig equations. You need to have it all in your head at the same time. And even a question like, say, which one was it? We were looking at it just now. Question 30, for instance, cos x minus sine x equals 1. Now when you have a look at that, what are we going to use? What's probably the best way to approach that question using our prior knowledge before we get to the general solution? Probably auxiliary angle, right? You could do it by t results, but because it's in it's a difference of wave functions, right? Cos and sine, and it's an easy one as well, one where the coefficients are really easy to deal with. You might as well put it into auxiliary angle and then go ahead and solve it. Write your solution like this. Okay? Any questions?
They ask you for like final solutions for n equals like 2, right?
Yep.
Up to 2.
Yep.
Wouldn't those two solutions work?
Yeah, so instead of, you're right, so you can see that these values of n or m or whatever, right, they will give you a different set of solutions. For instance, you know, these first 4 here, you've got to go, I only get them in the first 3 here, right? So n equals 2 for these sets of solutions would correspond to n equals 3 for this solution. So what they'll tend to do is rather than saying, give us the solutions up to n equals whatever, is they'll ask for the first 3, 4, 5, the first k number of solutions, right? Because that's going to be unambiguous depending on which form you've got. It'll be, 0, then pi on 6, then pi on 2, then you get the idea, okay? Or they'll give you a domain. they'll say, give us naught to 2 pi, or give us 2 pi to 4 pi, or give us minus pi to pi. And in that case, the form that you have is immaterial. You can use either one, and you'll still get the same solutions. Okay. Good question.